Tonight on The Future of Everything, we've got 3i Atlas updates and maybe even our best shot yet to clearly see the third interstellar object.
Astronomers last week, it could be the oldest comet ever seen.
Something unsettling is lurking at the fringes of our cosmic shore. The 3i Atlas, an interstellar visitor unlike anything humanity has truly studied in depth before, has been photographed in startling new detail by the European Space Agency ESA via its Mars orbiter craft. And the revelations are far more disturbing than simply another comet passing by. This ghost from beyond our solar system is upsetting expectations, defying categorization, and raising questions that dig at the foundations of how we think about objects from far beyond our sun's influence. The images show a body with a coma and tail and behavior that closely resemble a comet. Yet its composition and trajectory hint at something far stranger. Perhaps a relic of a distant stellar system, perhaps something more enigmatic. Before we start, smash the like and subscribe buttons for more updates. The journey of 3i Atlas began well beyond our immediate cosmic neighborhood. Discovered on the 1st of July 2025 thanks to the Atlas survey in Chile, it was quickly confirmed as the third interstellar object ever detected in our solar system. Back when it was first spotted, telescopes tracked its motion, establishing that it wasn't simply another member of our own system's comet population, but rather a wayfaring visitor that had drifted from another star altogether. As such, it carries with it the potential to tell us about regions of space never before sampled directly. But the new images revealed by ESA tell us that the visitor might be far more unusual than a simple interstellar ice ball. The new photos obtained by the Mars orbiters of ESA, namely the ExoMars Trace Gas Orbiter TGO and the Mars Express, captured 3i Atlas when it passed within about 30 million kilometers of Mars on the 3rd of October 2025. That proximity is unprecedented for this kind of visitor, and the images reveal a fuzzy, diffuse object with a coma of dust and gas, but lacking many of the markers we expect of standard comets. ESA itself noted that the observation was very challenging because the comet was orders of magnitude fainter than the usual targets of the imaging systems. The images show the object lurking against background star streaks. The spacecraft's imaging systems, used usually for bright Martian surface features, had to pick up a dim object many thousands times fainter than their usual targets. In the Hubble images taken earlier, the comet had been observed to have a teardrop-shaped dust cocoon streaming off an icy nucleus. NASA ESA's data showed the teardrop shape clearly, but the new ESA images push this further by revealing that not only is there the expected dust radiation and coma, but the gas outflow and composition are odd. Spectroscopic observations reported elsewhere indicate a coma dominated by carbon dioxide CO2 rather than water, with a CO2-H2O ratio far higher than normal for comets originating in our solar system. This implies that the material making up 3i Atlas is either formed under very different conditions or has been modified in ways we did not anticipate. What makes this even more troubling is that 3i Atlas seems to behave in a way that challenges standard comet models. For example, the tail or dust stream should be pushed away from the sun by solar radiation pressure. Yet some observations suggest the tail is being forced toward the sun rather than away. The scale of the object is imposing too. Estimates suggest the nucleus could be on the order of a kilometer or more, though some reports suggest even larger, making it a massive interstellar object by any standard. The combination of size, composition, behavior, and origin means this is not simply a routine piece of cosmic flotsam. The close-up images by ESA of 3i Atlas are disturbing because they reveal a shape and structure that seem to defy what we expect from objects tossed out of other star systems. The coma appears thick, the dust envelope quite large, yet the outgassing suggests an object that is resistant to typical decay behavior as it approaches the inner solar system. Some analysts speculate that such behavior could mean the object's surface has been processed, or possibly protected, in ways that shield it from rapid sublimation, something unlike known comets. Beyond the physical oddities, the trajectory and timing amplify the unease. A body coming in from interstellar space, making its way through our solar system at high speed, passing near Mars and now within imaging range of our craft. This is not a mere academic curiosity. The photographs released by ESA depict an object that appears almost sculpted. A visitor not just drifting through idle space, but interacting with solar radiation and solar wind in ways eccentric compared to usual solar system comets. There is a haunting implication in the fact that we now have photos from our own Mars orbiters of a visitor from another star system. It means that any object from afar can intersect our inner domain, be imaged by our spacecraft, and potentially leave information or perhaps even risk. Though 3I Atlas is not on a collision course with Earth, the fact that we can now capture and study such visitors means we must face the possibility that unexpected material with unknown composition and structure can enter our vicinity. And our observational capacity is only now catching up. The images show this object is closer than we often think such visitors will be. And so the window for data gathering is short, the margin for prediction small. Science is excited, of course. We yearn for the secrets such an object holds. What star system did it come from? What kind of ices and dust compose its body? How old is it? But the level of puzzlement is deep. The ESA released imagery forces the recognition that our models of comets and interstellar visitors may be inadequate. The new photos of 3I Atlas show that the visitor is not neatly aligned with expectations. Compositionally anomalous, structurally unusual, behaviorally odd. The disturbing part is that we may not yet have the vocabulary to describe it accurately. Consider the consequences. If an interstellar object can carry novel chemistry, unknown structures, and behave unpredictably in our solar system's environment, then it is a wild card in the cosmic deck. The fact that ESA's Mars orbiters captured images of it at close range means we are no longer passive spectators of such visitors. We are participants in their passage. These images show a once-in-a-lifetime opportunity, but also a risk. We may be encountering unknown types of bodies that humanity has never prepared for. In the photos, the glow of the object, the shape of its dust envelope, the dynamics of its movement all suggest a visitor that is both familiar and alien. One cannot ignore the philosophical impact of these images. Through the ESA images, we see material that formed in a star system beyond our own, arriving unannounced, being imaged by spacecraft designed primarily for another planet, Mars. That absurd intersection emphasizes how small our sandbox is in the grand scheme of the galaxy, and how little we still know about what drifts or flies through the interstellar void. The disturbing truth is that other star system debris can and does enter the solar banya of our sun, not casually, but with velocity and mass and mystery. The images of 3I Atlas compel us to confront that we are not isolated. We are connected and potentially vulnerable to the unknown. These new photographs also challenge our preparedness. For decades, comet science has relied on objects formed in our solar system, of known behavior, composition, and origin. But here, an object comes with a different chemical fingerprint, a different dynamic, and now we have images of its close approach. The images show dust and gas streams we cannot fully explain, and a tail alignment we do not expect. Will our planetary defense and observational architecture cope with these anomalies? The ESA imagery is a wake-up call. Interstellar visitors may not behave like our domestic comets. The images highlight a weirdness in motion as well. The path of 3I Atlas through the inner solar system is hyperbolic. It will not remain bound. It is here on a brief passage. That passage is now well documented thanks to the ESA images, capturing a snapshot of something not destined to stay. The fact that it came and is leaving, the images frozen in time showing the close encounter near Mars, is like viewing a ghost that passes through, leaving imprint after imprint but no intention to stay. The disturbance comes in the rapidity of its crossing, the ephemeral nature of the window we have to observe, and the uncertainty of what we are seeing. In the photographs, the coma appears to glow, dust trails stream back, stars streak in the background, and the spacecraft's sensors strain to pick up the faint object. But behind the beauty lies disquiet. What if an object like this carried unfamiliar volatiles or materials that we cannot easily classify? What if the dust is composed of exotic compounds, or the nucleus entails phases of ice that form only under the extreme conditions of other star systems? The ESA released images suggest the latter might be true, and if so, then our understanding of comets, the interstellar medium, and the feeding of material between star systems is incomplete. One particularly unnerving aspect is the composition ratio detected. The fact that CO2 appears dominant compared to H2O, far beyond the ratio typical of solar system comets. As the academic studies show, the CO2-H2O mixing ratio for 3I Atlas is at the high end of the scale, far outside the norm. That fact hints that this object could have formed in a colder, more irradiated environment, or closer to a different kind of host star, one that left its mark by locking in volatiles differently. The images from ESA, while mostly visual, complement that finding. The coma looks denser, the dust halo larger, the outgassing oriented differently. Another disturbing feature is that the tail orientation is odd. Dust and gas ejected from comets are usually blown away from the sun, but observations suggest 3I Atlas has a tail that is somewhat sunward. That suggests forces besides solar radiation pressure may be at play. Perhaps solar wind, electromagnetic effects, or some internal engine of alteration. The images from ESA's Mars orbiters cannot fully resolve all these, but they provide the context for such strange behavior. The significance of the ESA photographs lies not just in capturing a rare visitor from another star system, but in showing us that such visitors might be far more exotic, far more dangerous in the sense of unknowns than we presumed. The pictures depict something that is no simulation, no speculative abstraction, but concrete, an object with mass, motion, chemistry, and mystery. Humanity has now tangible visuals of extraterrestrial material passing through our backyard. And those visuals don't comfort, they disturb. They whisper questions. How many more such objects silently drift through space unseen? What surprises may they carry? Do we even know how to look for exactly such odd behavior before one comes too close? In the new images, one can sense the scale of the event. A spacecraft orbiting Mars turns its camera to catch a visitor from beyond and sees a faint dot against inorganic cosmic background. Yet that dot holds within it the history of another star system, perhaps kilometers of icy rock and dust, echoes of planetary formations somewhere else. The fact that we captured it mid-pass is remarkable, but also sobering. It passed close to another planet entirely Mars before we were fully prepared for it. If humanity is to study interstellar visitors in the future, we must treat them not as curiosities but as potential entries into our solar system's dynamics, composition, and risk matrix. The images released by ESA show a celestial interloper, yes, but they show one that might not fit into our neat classification of comets. The revelation is disquieting because it suggests that the universe does not hand us convenient categories. It suggests there are objects out there formed under conditions quite different from our solar system, visiting us without invitation, leaving little trace but immense questions. Being able to capture such an object through Mars orbiters is a milestone. But it is also a warning. Our observational net is not yet fine enough, our preparation not yet adequate, our models not yet complete. We now have what looks like video frames of a relic from another star system, captured by ESA's TGO and Mars Express, showing an icy body with an uncommonly volatile composition, a dust and gas envelope not quite conforming to expectations, and a tail that pushes against solar influences. We see in those images not just science, but a reminder of how fragile and little we understand of cosmic travelers. The fact that such an object was imaged so near another planet invites us to think, what if other such objects come closer? What if one arrives unexpectedly with a different composition that interacts with solar wind or planetary atmospheres in ways we underestimate? The ESA images of 3I Atlas force us to shift from theoretical to tangible. Interstellar objects are here, and they may not behave like the comets we know. This isn't simply a beautiful cosmic photograph. It is a moment in time when humanity saw something extraordinary and had to ask, are we safe? Are we ready? What are we seeing? The new ESA released photos of 3I Atlas bring us face to face with an alien visitor whose properties challenge our assumptions, whose very existence raises questions about what lies beyond the familiar boundary of our system. In that sense, the images are disturbing, not because they depict a monster or an impact threat, but because they expose our ignorance and show that we may only be scratching the surface of the kinds of interstellar visitors that can pass through. In those visuals, we see dust glowing, gas streaming, a mundane-looking object with profound implications. The disturbing part is not just the composition or trajectory, but the fact that the visitor is so anomalous and yet so real. It demands that we broaden our cosmic perspective, rethink how we prepare for unknowns, and accept that the universe contains materials, behaviors, and paths we have barely begun to comprehend. The images of 3I Atlas captured by ESA bring home the chilling realization that our solar system is not an isolated fortress but a transit point, a place through which foreign objects pass silently, carrying secrets, and in some cases, serving as mirrors to other star systems, other histories, and other compositions. The new photos released by the European Space Agency ESA capture a moment of confrontation with something utterly foreign, the interstellar visitor designated 3I Atlas. The images themselves might appear almost benign. Swirls of dust and gas, a faint nucleus, a tail lancing away from the sun. But what lies beneath is a far deeper disruption of our cosmic assumptions. This is not simply another comet. It is a messenger from another star system, carrying with it the blueprints of alien formation, the fingerprints of distant chemistry, the traces of eons of galactic drift. And as these photographs reveal, the visitor is far stranger than even the most speculative models predicted. The moment the images were made public, the scientific community was jolted. For decades, cometary science has been rooted in objects formed in our own system, bound by the sun's gravity, composed of familiar ices, dust, and rock moving along predictable orbits. But here's 3I Atlas, hurtling through on a hyperbolic trajectory, never to return, with an origin outside our solar system. The ESA photographs show a halo of dust that is larger than initial ground-based estimates, a coma that appears more active than expected at the current heliocentric distance, and structural features that don't map neatly onto our catalog of known comet shapes. These images bring into stark relief how little we truly understand about what objects from outside our system can be like. As the spacecraft orbiting Mars captured the object during its flyby at roughly 30 million kilometers from the red planet, the images betray a large, ghost-like presence, one that looms faint yet unmistakable against stellar backgrounds. The dust envelope seems to span an area that, scaled to Mars's position, ought to be smaller for a typical solar system comet of this brightness. Yet 3I Atlas defies that expectation, suggesting either a much larger nucleus or far greater dust production, or both. ESA's own announcement acknowledged the very challenging nature of capturing such a faint object with instruments designed for brighter Martian targets. And what they captured that day in early October 2025 is nothing short of astounding in its strangeness. One of the most profound implications of the images is the degree of activity exhibited by 3I Atlas at considerable distances from the Sun. Comets from our system typically begin exhibiting strong outgassing and dust release as they warm significantly. But here, the dust halo appears well established, and the gas envelope large even before the object has passed into the inner solar system proper. The ESA imagery shows diffuse structure, streams of dust, blurring of the background stars as the instrument tracks the moving object, all contributing to a sense of motion and purpose, not mere drifting. The object appears almost to be preparing itself, ready for the solar encounter, already shedding material in expectation of heat rather than reacting for the first time. That preemptive activity is cold comfort. It means the rules we thought applied do not fully apply here. When these photographs are paired with spectroscopic and infrared observations from other observatories, a broader picture emerges, and it is unsettling. The high ratio of carbon dioxide to water, the unexpectedly large size estimates of the nucleus, the advanced dust production, all these suggest that 3I Atlas was formed under conditions very unlike those in our own solar system. The ESA imagery thus serves as a visual anchor for the deeper, harder questions. What kinds of star systems cast off such objects? What materials freeze and survive for billions of years in interstellar space? And once such an object plunges into a star's domain, ours, how does it respond? The photographs show a body awakening, but they also hint at the possibility that its awakening follows a schedule we have not prepared for. Another dimension emerges from the trajectory and timing revealed in the imagery. 3I Atlas entered our sphere as a high-velocity interloper not bound to the Sun. The photographs capture it during a segment of its passage, the first time an interstellar object has been viewed so closely by planet-orbiting spacecraft. That alone is historic, but it also hints at what might occur in future. Bodies from other systems, driven by unknown processes passing through ours, offering fleeting glimpses but rarely staying long enough to allow deep study. The ESA images of 3I Atlas act as a wake-up call. We are capable of catching such visitors, but perhaps only just in time. In those images, we see not just dust and ice, but the record of a journey across the galaxy. The faint streaks behind the object, captured as it moved against background stars, are trails of ancient history. The dust being shed might contain materials forged around other stars, exposed to cosmic rays, ice sublimation cycles, interstellar radiation fields far harsher than our own. The photos show a moment of transition, from interstellar solitude to solar assault, from frozen far wanderer to active body in the warmth of our system. That transition is messy in the images. Irregular dust jets, an asymmetrical coma, possibly uneven surface features or fragmentation. But the mess is telling. It tells us this journey is unique, and that our models need to account for more than the standard solar system paradigm. Perhaps the most disturbing aspect of the images is the suggestion of scale. The dust cloud captured by the Mars orbiter appears to rival the size of moons we know in terms of sheer volume of ejected material. If the nucleus is indeed near the upper end of current estimates, then 3I Atlas may be one of the largest interstellar objects ever recorded. The photographs show a body that is not negligible, it commands attention, and a large interstellar object is a concern not because it's headed for impact, but because large means substantial, means storage of heat, means longer activity, means greater input into the inner system environment than we might expect from a smaller visitor. The images show something that could leave a significant imprint, not just for science, but for solar system dynamics. The shapes hinted at in the images, elongated dust trails, potential fragmentation signatures, jets of material streaming in different directions, raise the prospect that 3I Atlas is not simply a standard comet. It may have undergone events earlier in its life, collisions, close stellar passages, exposures that chipped its surface, triggered outbursts. The ESA pictures show faint wisps, ghostly tails, and a nucleus halo that is uneven, not smooth. That unevenness speaks to a history of trauma, drift, survival. It suggests that when bodies leave their home systems, they carry scars. The images of 3I Atlas carry those scars visually, offering a narrative of endurance across eons and light years. Because of this, the photographs provoke uncomfortable questions about our observational readiness. If an object from another system can enter our solar domain, pass within tens of millions of kilometers of a planet Mars in this case, and be only faintly imaged by orbiting spacecraft, what other objects might have come or will come undetected? The fact that ESA's Mars orbiters had to scramble to capture images of 3I Atlas is instructive. These spacecraft are built for Mars science, not interstellar surveillance. Yet here they are, turning their cameras to an intruder. The images thus are not just of the object, but of our own limits. They show both our reach and our lapses. The visual evidence from ESA also underscores the temporal urgency tied to such encounters. The time frame during which 3I Atlas is close enough for detailed imaging is short. The photos reflect the narrow window of observation. The object is inbound, will make its closest approach, and then it will be gone, back into interstellar space. The images show a fleeting cross-section of its life. That fleetingness is disquieting because it means that much of the object's journey, its prior history, and its subsequent fate are outside of observation. We are seeing only a few frames in a vast journey. The photographs emphasize how ephemeral our chance is to capture such visitors. In particular, the images capture moments when heating from the sun begins to activate the object. Dust mobilizes, gas is released, the coma expands. The photograph's detail of the dust halo interacting with solar radiation pressure and solar wind reveals nuance. The tail may be skewed, the dust cloud may be offset relative to the nucleus. That suggests the object's surface and internal structure respond differently than our familiar models predict. The echo here is subtle. If an object's response is unlike ours, then the assumptions underlying our detection and analysis methods may need revision. The ESA photographs of 3I Atlas thus stand as both record and challenge. Another unsettling element arises when one contemplates what the object leaves behind. The images show dust streaming off 3I Atlas. That dust will mingle in the solar system, interacting with solar wind, possibly with planetary magnetospheres, or perhaps eventually join other debris systems. The photos record not just the visitor, but its shedding. Material leaving one star system, entering another. That exchange is rarely witnessed, yet the ESA photographs might be capturing it. If so, we are witnessing the transfer of material across interstellar space. Material that once captured could seed planets or belts in other systems. The implications are immense. These images may be documenting not just a visitor, but a cosmic courier of matter between star systems. There is also the psychological dimension. The visual representation of 3I Atlas, its sparse nucleus, enormous dust cloud, hyperbolic path, is alien in a way few space photographs are. The ESA imagery evokes loneliness, the sense of something that has drifted for billions of years before being caught in the sun's wake. The images allow us to appreciate our position in the cosmos, not as isolated, but as part of a broader network where materials travel. The disturbing undercurrent is that we thought of comets as primarily solar system phenomena. These images tell a different story. Comets may be communal experiences of multiple stars, shared across the galaxy. When you look at the ESA photographs of 3I Atlas, you are also looking at a reset of baseline. Our previous interstellar objects, such as 2I/Borisov, were small, faint, and fleeting. But the visual magnitude of this visitor, captured by Mars orbiting instruments, is more substantial. The images show that interstellar objects cannot be taken lightly. The fact that such an object was observed not only by ground telescopes but by orbiting spacecraft means we are entering a new era of interstellar visitations, and the ESA images mark a kind of pivot. The photographs underscore that interstellar objects are not just curiosities. They are accessible, studyable, and consequential. What the images do not show is the full story. They cannot reveal the interior of the nucleus, the exact distribution of volatiles, the full three-dimensional structure of the coma. But they do hint at anomalies. Dust jets might be curling away, a sunward streamer might be seen, the shape of the coma might be lopsided. That asymmetry hints at internal forces, variable surface strength, perhaps even fragmentation in progress. The pictures prompt us to ask, what if this object breaks apart? What if the fragments scatter? What if the material released poses a hazard or introduces novel chemistry into the inner system? The ESA images offer a glimpse of these possibilities without providing certainties, but the glimpse is enough to raise unease. Indeed, the images suggest that 3I Atlas may not have a simple life cycle. Comets from our system often pass through perihelion and fade away, perhaps shedding material but generally predictable. But here, the object may endure. With a large nucleus, high volatile content, and an active dust production rate, 3I Atlas could continue to show activity past perihelion, perhaps longer than typical. The images hint at this because the dust cloud appears already extensive. The disturbing implication is that this visitor could drive changes outside the immediate sun approach window. Its passage may have downstream effects, increased dust flux in inner solar system regions, changes in solar-wind interaction, or even micro-impacts of dust on orbiting spacecraft. The ESA visuals make this possibility more concrete. And there is another facet. The images speak to origin. The shape of the dust halo, the trajectory captured, the implied tilt of the tail, all provide clues to the object's past. For instance, the tilt suggests that 3I Atlas may have entered the solar system at a steep inclination, one that does not align with the ecliptic plane. That itself is disturbing. Objects entering at odd angles may carry kinetic energy, dust and gas distribution patterns quite distinct from those oriented to our system's plane. The photographs therefore imply that our solar system is vulnerable to material arriving from strange angles, directions, velocities. We are not just a coin in a flat pond, but rather exposed in three-dimensional galactic space. The images of 3I Atlas remind us of that exposure. These photographs also invite the uncomfortable thought of monitoring and detection gaps. If 3I Atlas was already active when discovered, and the images confirm that, the object might have been passing through for a while, albeit faintly. The ESA images were grabbed after trajectory confirmation, but they highlight how faint and how fast such objects can be. If we missed the early phase, what else might we miss? The images thus are both achievement and indictment. We have the ability to capture such phenomena, but only if we are ready and looking. And readiness means instrumentation, telemetry, coordination across spacecraft and ground observatories. The ESA images raise the question, are we truly prepared for the arrival of the next interstellar visitor? Perhaps one more massive, more active, more divergent? There is also a sense of cosmic humility embedded in the visuals. The images from ESA show 3I Atlas as a small dot in wide frames, but that dot represents years of travel, unknown origins, and an eventual exit back to interstellar space. When we view these photographs, we confront the fact that our sun's gravitational domain is but a stopover for this object. That shift in scale, the sun as a temporary host rather than dominator, forces a rethinking of our place. The ESA photographs symbolize a migration through our system, not a residence. And that migration is one way. The disturbing truth is that interstellar objects may pass through regularly, but only rarely do we capture them. The images of 3I Atlas thus are precious, but also reminders of the many we do not see. The ambitions of science aside, the images carry an existential undercurrent. Objects from other star systems can come through our home, briefly illuminated by our sun, then leave. The photographs of 3I Atlas captured by ESA's spacecraft underscore that the borders of our solar system are permeable. Dust, ice, rock from elsewhere can drift in. The images show one such incursion, but the implication is broad. It means that material exchange across galaxial distances is not just theoretical, but observable. The disturbing part is that we previously assumed our system to be relatively isolated with respect to large active objects from outside. The ESA images challenge that assumption. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on the new 3I Atlas photos ESA just revealed? We want to hear from you. Thank you for watching and see you next time.